Okay, so today we are going to focus on applications of these sinusoidal graphs and equations. And it's going to seem really similar to what we did before. When you're given a graph, you have to write an equation, except we're going to have an extra step where we have to sketch our graph with the data that were provided. So our first problem here says, the following table gives the average monthly Fahrenheit temperature for Des Moines, Iowa. Graph the data and then find a sine function. And by sine, they mean sinusoidal, so sine or cosine. You get to pick your favorite. And then I added a question A and B at the bottom that we're going to use with our information or with our equation. So first, when I'm looking at this information, I want to know the low point and the high point, the minimum and the maximum. I'm going to look through my temperatures, and we got the low of 20.8 degrees and then a high in July. And when I graph this, my X is going to be time. So let X be 0 for January. So this is month 0, month 1, month 2, month 3, month 4, month 5, 6, 7, 8, 9, 10, and 11. I'm not going to use the grid. I'm just going to make my own scale. So I'm going to say the low here is at 20.8 and the high is 76.1. On my x-axis, month 0, and then I can count the grids for the 6 months. So we got 1, 2, 3, 4, 5. So here's month 6, 7, 8, 9, 10, 11, 12. And then I'm going to plot the points. I got my low at month 0, my high at month 6, and then we know sinusoidal functions repeat themselves. We have that period. So in 6 months again, we'll be back at the low. So this was 6 months, and then another 6 months. I'm going to connect my points. Whoops, I missed. Oh, come on. Third time's the charm. And you can see one period of our sinusoidal graph. So now we have to find all the A, B, C, D values for our equation. So the amplitude, we can find the amplitude by taking the maximum minus the minimum and dividing by 2. You can use a calculator for this. I'm going to pull up the Desmos calculator. That's the scientific one. We get 76.1 minus 20.8 divided by 2. 27.26. I'm sorry, 27.65. So our amplitude is 27.65. I like to find the midline next, that vertical shift. So I'm going to add my maximum and minimum. This time I'll actually put parentheses and do it in one step. $48.45. And then our B value, we get that from the period. So that's 2 pi over the period, which would be 12. We reduce that to pi over 6. And then we're going to skip number 2. Whoops, that's all attached. So you can use the space, either cross off number 2 or just work around it. So now we go to write our equation, and I prefer to pick cosine because either we can do a reflective cosine with the minimum or a positive cosine here at the max, and that's going to change our C value. So I'll write both. We got y equals amplitude cosine be x plus the midline. And so the difference is, if I'm going to pick a positive cosine graph, my horizontal translation is to the right 6. If I want to pick a negative cosine graph, I have a reflection translated nowhere. So now we're going to add part A and B to your paper. Find the temperature in March using your equation. So specifically using our equation, not the table of values. March, remember, was the month 2, because 0 was January, February, March. March is month 2. So you can pick either one, and I'm going to pull back up my calculator, and I'm going to actually use the graphing calculator, so that way I can do part B at the same time without having to switch. So pick your favorite function. I'm going to use the reflected equation to type that in. So we got y equals negative. If you type pi, it gives you pi. What? I don't want it like that. We'll do parentheses. Pi divided by 6, parentheses x plus 48. And you don't see a graph here because it's been shifted up and over. So I could drag this. There it is all the way up here. But we'll get to the graph part in a minute. I first want to find when x is 3. So there's a really cool function with the Desmos Graphing. If you click this edit gear here and click the table, I can type in 3 and it shows me 48.5. So the temperature, oh, wrong. Did you catch that? I typed in the wrong thing. It should be 2, which is actually down here. 34.625. So y is going to equal 34.625 degrees Fahrenheit in March. So to use the graph to find the month where we hit 70 degrees, if I look at my graph up here, so 70 is close to 76. And if I sketch that vertical line at 70, this point and this point are going to be the 2 months where the temperature is approximately 70. So let's use the calculator to get that. I don't want this table anymore, so I'm going to go back to the gear and hit done. No, I'm not. I want my equation. Okay, I'm going to hit the back arrow. And then in 2, I'm going to type y equals 70. That's that temperature. So since the window is not helpful, I'm going to go to this wrench for the settings and fix my window how I want it. I know my months go from 0 to 12. And I'm going to use this y-axis to help me. I'm going to have my y-axis go from 0, and I'm going to round up to 80. It's radians because of that pi over 6, so that's good. Click the wrench, and there is a picture that matches what I have drawn here. Now, what I really love about Desmos over the TI calculator is I can click, and it tells me the 2 months where my graph reaches 70 degrees. I'm going to bring that over into our notes here. So month 4.7 is, we're going to say, the end of March. That's when X is 4.707. I'm off on my months again. Geez, 0 is January, 1 is February, 2 is March, 3 is April, 4 is May. Yikes, Miss Weiss, get it together. So 4.7 is the end of May, 5 is June, 6 is July, 7 is August. And then this 7.29, we're going to say the end of August, which is X is 7.29. Oh, it's not really the end. Let's say the beginning. That's 2. I was thinking the 9. 7.2, let's say the beginning of August. Okay, we're going to skip number 2. Here's our quick announcements. It's the short week. We have a check-in time Thursday afternoon. And the homework, there's going to be one homework problem for you to submit today. Today is your asynchronous independent day. You do have to submit the one homework assignment today. All right, so let's do another. Number 3, now we've got water at a dock. I want you to sketch your graph. Midnight is 0, so let's see for the low and the high. Here's my low. Here's my high. No, oh, midnight is not the low. It is not. Here it is. That's let's use appropriate math words here. Minimum and maximum. So the minimum is 1.8. The maximum is 4.4. Here's 4. 6, 7, 10. Now, I only have half a period here. The length between 4 and 10 is 6, so I'm going to go out another 6 units to get back to our maximum. All right, let's write our equation. Amplitude is max minus min divided by 2. Vertical shift is max plus min divided by 2. And I'll calculate those in a minute. E is 2 pi over the period. So let's figure out the period. From 16 to 4 is the period. And that is a length of 12. Okay, let's calculate our amplitude and midline. Oh, that's tricky. They're reverse of each other. So the amplitude is 1.3. The midline is 3.1. Again, I'm going to pick a cosine graph. I don't know where the midline and what time that happens at. I'm going to pick a cosine graph and shift to the right 4 because that's where this first maximum is. So we got y equals a cosine b x to the right 4 plus midline. Use your equation to find the depths at 9 and 3. Now this 3 is tricky. So 9 a.m. is 9, but 3 p.m. is past noon. So you kind of even have to think at military time. So if noon is 12, 1 p.m. is 13, 2 p.m. is 14, so 3 p.m. is 15, when time is 15. I'm going to update my function here. Yes, 1 second, Hallie, I'll help you. But I want the table of values. I don't want the graph just yet. So I'm going to hit the gear, go to the table, and I care about when time is 9 and 13. No, 15. Sheesh, 15. All right, so that is a height. At 9, we have 1.974 feet. And at 15, 3 p.m., 4.226 feet. Oh, it's meters. Holy cow. Meters, meters. So now if the dock needs at least 3 meters, if the boat needs at least 3 meters to dock, what time can it dock safely? So we go back to our graph. I'm going to go back, and type y equals 3. And then notice my graph's all the way down here. So I can either click and drag. I can use the plus or minus. I'm just going to reset my window again. Go 0 to 16. I'm just going to round up to 10. There's a nicer picture. That's even better. Now I can see my X and Y axis. So here's the 3, the 3, the 3. And I didn't ask for all these times, but I'm going to get them because I don't remember. And I'm going to go back to my work here. Wow. And figure out what they're asking us. Okay, if a boat needs at least 3 meters, during what time in the afternoon can it dock? So I actually don't think I have enough yet. Let's go to 24 hours, a whole day. Now, I don't know if afternoon considers evening, so let's just get all of these points again. Update this. All right. During what time can it dock safely? So remember, this is midnight. And then let's see, afternoon. Well, so this is still 7 a.m. Ah, so this is a little bit, so this is almost 1 p.m. And then this one, so 15, 16 is 4, 17 is 5, 18 is 6, 19 is 7 p.m. So this is 7 p.m. So for this one, what times can it dock safely? I'm going to say 1 p.m. and 7 p.m. Okay, so number 1 here on the next page, that's another temperature one. We just did that. I'm going to skip that one and go down to number 2 with this Ferris wheel. Don't panic. I know we did a ton of Ferris wheels in Algebra 2. It will be all right. We don't have a picture or a table of data this time. So instead, we have to come up with it ourselves. So it says, assume a Ferris wheel is 50 feet in diameter. This length is 50. It makes 1 revolution every 9 seconds. That's our period. And the bottom is 3 feet off the ground. So that means the top will be at 53 feet. So if I'm going to sketch a picture to help me write my equation, assume when x is 0, the passenger is getting on right at the bottom of the wheel. So that's at 3 feet. It takes 9 seconds to go all the way around. So halfway will be at the top for 53 feet. All right, you write your equation. And then hit pause, write your equation, and then unpause to see the answer. All right, so A, 53 minus 3 divided by 2 is 25. The midline, 53 plus 3 divided by 2 is 28. B is 2 pi over the period. And now let's write our equation. So y equals 25 cosine 2 pi over 9. X, I'm going to shift to the right 4.5 because that's where the maximum is. That's 28. Okay, predict the height when time is 5 and 12. Get out our handy calculator here. Get rid of this one. We got 25 cosine 2 pi divided by 9. X minus 4.5 plus 28. All right, let's see if I can use my table correctly this time. Hit the gear, go to table, and we want 5 and 12. Oops. Move my B work down here. All right, so the height is 51.492 feet. At time is 5, and the height is 40.5 feet. At the time is 12. Okay, so your job then, we're gonna skip that one, is to do this wrecking ball problem and submit that in Canvas today.